Welcome, weary traveler, to this quiet corner of the night. You've arrived at a space where the world's frantic pace is replaced by the slow, deliberate rhythm of the cosmos. Tonight, we will not chase solutions or demand certainties. Instead, we'll simply float like a feather on a deep, dark sea in the presence of one of the universe's most profound puzzles. We are going to gently unspool the story of Cygnus X-1, a name that sounds like a piece of technology, but is in fact a whisper from a hidden world. It is the tale of a cosmic predator hiding in plain sight, a story that bridges the gap between what we imagine and what is truly real. So find your softest spot, let your breath slow, and allow the mind to quiet. We will move at the pace of starlight, and our goal is not to reach a destination, but to simply marvel at the journey itself, a gentle exploration of the vast, beautiful questions that lie just beyond the edge of our vision. Imagine for a moment the world in the early 1960s. Our view of the cosmos was like a library filled with books, but we were only able to read the ones written in a single language. We had magnificent optical telescopes that could peer deep into the night, capturing the beautiful visible light from stars and galaxies. It was a universe of tranquil nebulae and shimmering starlight, a majestic but seemingly predictable place. We believed we had a good grasp of the story, based on the narrative our eyes could perceive. But what we didn't know was that there was a whole other collection of books written in a different, more energetic language waiting to be read. These books, full of tales of immense power and cosmic violence, were hidden from us by a simple, elegant barrier, our own atmosphere. That beautiful blue blanket of air that keeps us warm and lets us breathe is also a perfect shield against the most high-energy light from space, including X-rays. For billions of years, cosmic X-rays have been bombarding our planet, but they've never once made it to the surface. It was a cosmic secret, a hidden layer of the universe's tapestry that remained tantalizingly out of reach. To glimpse this secret world, we had to do something that felt both a little mad and profoundly brave. We had to send our eyes above the atmosphere on a journey that lasted for mere minutes. These were the birth pangs of a new kind of astronomy, not from a grand observatory on a mountaintop, but from the quiet, determined launch of a rocket. The story of X-ray astronomy begins with a small team of scientists led by a man named Riccardo Giacconi, who were trying to do just that. They weren't looking for anything specific. Their instruments, carried on suborbital rockets, were simply designed to go up for a short while, peek over the atmospheric wall, and see if anything was out there. It was like dropping a net into an ocean you thought was empty. The flights were brief and expensive, and the detectors were a little crude. But the hope was a quiet, steady one to simply see if a new kind of light, a new story was being told. In 1962, on one of these early tentative flights, their instruments sent back a powerful, stunning discovery. Instead of a faint, uniform glow, they had expected they found a single, incredibly bright source of X-rays in the constellation of Scorpius. It was a moment of profound, quiet shock. They had not dropped a net into an empty ocean. They had dropped it into a torrent. It was as if they had been listening to a silent room, and suddenly a giant speaker began to hum with an unexpected and powerful melody. This was Scorpius X-1, the first known celestial X-ray source, and it marked the beginning of a new era. It was a sign that the universe was not just a serene painting, but also a wild, energetic, and fiery drama playing out in a frequency we had never been able to hear. But our journey tonight leads us not to that first discovery, but to a deeper, more enduring mystery. 2 years later, in 1964, another team conducted another suborbital rocket flight, this time with even more sensitive detectors. They turned their instruments to a different part of the sky, a region in the constellation Cygnus the Swan. The constellation itself is a beautiful, familiar sight, a celestial bird soaring gracefully across the Milky Way. But tucked away within its quiet, majestic wings, the detectors found something remarkable. They found another powerful X-ray source, but this one was different. It wasn't a steady humming light. It was a flickering, frantic, and highly variable signal. It was given a name that would echo through the history of science, Cygnus X-1. This was not a discovery that came with a moment of instant clarity. It was a slow, patient process of unraveling a cosmic knot. The initial discovery was simply a data point, an oddity that needed to be explained. Scientists began a long, methodical investigation. They tried to make it fit into the existing framework of celestial objects. Perhaps it was a supernova remnant, the leftover shell of an exploded star. That seemed plausible, but it didn't quite explain the sheer power and the rapid flickering of the light. Maybe it was a rapidly spinning neutron star, a pulsar. That too was a good guess, but as the years went on, the data kept pushing back, insisting that something about this object was fundamentally wrong. Fundamentally different. The name itself, Cygnus X-1, tells this story of patient inquiry. Cygnus for the constellation. X, to denote that this was a discovery made in the X-ray spectrum, the new language of light they were learning to read. And 1, because it was the first, most prominent source they had found in this particular region. It's a name that sounds simple, but it represents years of quiet work of hypotheses built and then gently dismantled of a community of brilliant minds trying to listen to the whispers of an unknown universe. The real breakthrough, the moment when the mystery began to take on a tangible form, came in the early 1970s. By this time, astronomers had better telescopes and were able to observe the region of the sky where Cygnus X-1 was located with incredible precision. They began to see something that had been hidden before. The X-ray source wasn't alone. It was part of a cosmic dance. They found that Cygnus X-1 was located in the same space as a large, bright, and very beautiful blue supergiant star. This star, massive and brilliant, was an entity of life and light. But what truly astonished them was how it was moving. It was locked in a tight orbit, a fast and furious waltz around an invisible companion. This was the quiet and stunning climax of the first part of our story. The blue supergiant was not orbiting an empty patch of sky. It was orbiting a ghost, a presence so heavy and so powerful that its gravitational pull was undeniable. The blue star, in its graceful dance, was literally being tugged and twisted by an unseen hand. The next step was to measure the mass of this invisible dancer. By observing the speed and size of the blue star's orbit, astronomers could use the simple, elegant laws of gravity to weigh its mysterious partner. The result was a number that defied all existing explanations for known celestial objects. The invisible companion had a mass of at least a dozen times that of our Sun, a density so immense that it could not possibly be a normal star, and was far too heavy to be a neutron star. At that moment, the impossible became the only possible answer. The only object that could exist with that much mass packed into such a small invisible space was a black hole. A black hole which was, at that point in history, still largely a theoretical construct, an elegant but seemingly fictional solution to Albert Einstein's equations. Cygnus X-1 was the universe's proof of concept. It was the moment a ghost in the machine was given a location, a mass, and a tangible, if unseeable, reality. The flickering X-rays, so puzzling for so long, were suddenly understood. They were the last desperate screams of matter as it fell into the ultimate abyss, a cosmic maelstrom created by a thing that was not supposed to be. The quiet debates that followed were some of the most fascinating in the history of science. On one side, you had those who were thrilled, who saw Cygnus X-1 as the long-awaited proof that black holes were real. On the other side, you had the skeptics, including some of the most brilliant minds of the era, who still believed that there had to be another explanation. The stakes were so high, the concept so radical, that it was hard to simply accept. One of the most famous of these skeptics was Stephen Hawking, who even made a now-famous bet with his colleague Kip Thorne, wagering that Cygnus X-1 was not a black hole. It was a bet that Hawking would later concede, a testament to his own intellectual honesty in the face of mounting undeniable evidence. The story of Cygnus X-1 is a story about the triumph of evidence over assumption. It is a story about how science doesn't demand that we believe, but that we observe and let the universe reveal its secrets on its own schedule. The quiet, persistent efforts of a few scientists sending small rockets into the dark and listening carefully to the whispers that returned fundamentally changed our understanding of the universe. It was the moment that the abstract, poetic equations of physics were shown to be a literal map of reality, a guide to a world far stranger and more beautiful than we had ever dreamed. So as we close this first chapter, let us simply rest in the beauty of that initial discovery. We began with a universe that we believed was a serene optical painting. We now know that it is a vast, multi-dimensional symphony with a hidden layer of energy and power that we are only just beginning to perceive. The flickering light of Cygnus X-1, a powerful beacon of X-rays in the constellation of the Swan, was the first note of a song we had never heard before. It was the first clue that in our peaceful, familiar night sky, there was a cosmic secret, a beautiful and terrifying mystery waiting to be found. And that mystery, as we will explore in the coming chapters, is not just about what this object is, but about the beautiful, deadly dance it performs with its companion, a waltz of gravity and light that holds the keys to understanding the heart of our cosmos. We'll take our time, as we always do, to let this thought settle. The universe is full of hidden depths, and sometimes the most profound answers are found not by looking for what we expect, but by listening for the quiet whispers from the most unexpected places. And in the case of Cygnus X-1, that whisper was a frantic scream of X-rays, a signal that opened our minds to a truth that was stranger and more magnificent than any fiction. This is where our story truly begins, at the edge of the known, where the first physical evidence of a black hole changed everything. Let us now drift a little closer to the cosmic stage, where our story unfolds, a stage set in the vast and quiet darkness of the Cygnus constellation. In the last chapter, we listened to the first whispers of a black hole, a signal that came from a place no one expected. Tonight we will look at the source of that signal, not as a single isolated mystery, but as a celestial partnership, a powerful and poignant dance between two very different performers. This is the tale of a binary system, a world where a massive, brilliant star is locked in an eternal waltz with a tiny, invisible companion of unimaginable power. Imagine a grand, dark ballroom in the cosmos. On one side of the floor, a towering figure dances, a magnificent and radiant being. This is HDE 226868, the blue supergiant star, the visible and luminous half of our duo. It is not just a star, but a celestial monarch, a king of light and heat. It burns with an intensity so fierce that its surface temperature is around 30,000 Kelvin, a searing furnace that makes our own sun seem like a gentle hearth. It is colossal, a great bloated orb of hydrogen and helium, some 40 times more massive than our sun, and so immense that if you placed it in our solar system, it would extend far beyond the orbit of Mercury, perhaps even halfway to Earth itself. Its brilliance is a fleeting one, a life lived in fast forward. Unlike our sun, which will shine for billions of years in a steady, calm manner, this star is burning through its fuel at a furious, almost reckless pace. It is a star living a short but spectacular life destined for a dramatic end. But as the blue supergiant dances, it is not alone. Its partner is a presence felt, not seen. This is the invisible half of the duo, the enigmatic force that we now know to be the black hole. It is a tiny, silent, and immensely powerful partner in this waltz. While the blue supergiant shines with the power of 50,000 suns, the black hole emits no light at all. It is a point of utter darkness, a tear in the fabric of space-time itself. It is a paradox. The most influential and destructive force in the relationship is also the one that is utterly and completely invisible to our eyes. And what a dance they perform! This is no gentle romantic waltz. This is a powerful gravitational tango, a furious and tight orbit where both dancers are inextricably linked. They spin around a common center of mass, a point between them that is closer to the black hole because of its staggering density. Imagine a child on a playground seesaw with a grown adult. The child has to be much farther from the centers to balance the adult's weight. In this cosmic version, the adult is the tiny, invisible black hole, and the child is the immense, shining supergiant. The black hole, though small, is so heavy that it forces the star to orbit it, controlling the rhythm and tempo of their beautiful and deadly ballet. Their entire dance cycle, one full orbit, takes just 5.5 days, a dizzyingly fast pace for objects of such size. It is a cosmic dance where the light and life of one partner is slowly, deliberately being pulled into the darkness of the other. This is the central engine of our entire mystery. The reason we can even see the black hole at all is because of this intimate close-quarters dance. The blue supergiant, in its furious existence, is constantly shedding mass. It has powerful stellar winds, a constant outflow of gas and matter that it pushes into space like a great ship with a full sail constantly in motion. But in this tight dance, the black hole is positioned perfectly to intercept that outflow. It's like a silent cosmic vacuum cleaner, perfectly placed to pull in the precious particles from its companion star. The black hole is a gravitational predator, and the blue supergiant is its unsuspecting, magnificent prey. The black hole is not actively chasing the star, it is simply positioned perfectly to feed on its natural effluence. Let's pause on this idea for a moment. This isn't a single cataclysmic event. It's a slow, steady, and relentless process. The blue supergiant is a cosmic giant, and the black hole is a patient, silent king. As the star orbits, its immense size means that its outer layers, the very furthest reaches of its great shining atmosphere, are within the gravitational grasp of its tiny partner. It's like a great overripe fruit being slowly, gently, but inevitably pulled apart by a tiny but immensely strong hand. The matter from the star doesn't fall directly into the black hole. It is first captured by its gravity and begins a new violent journey. This is where the story gets really interesting and where the invisible begins to reveal itself. All of this captured stellar material, the gas and the dust from the blue supergiant's outer layers, doesn't simply vanish. It begins to spiral, to circle around its new master. It's like a whirlpool, a great spinning vortex of matter and energy. But this is no gentle whirlpool. This is a place where things begin to heat up, to accelerate to unimaginable speeds, and to shine with a light that is not visible, but whose effects are undeniably there. This vortex, this great spinning disk of stolen starlight, is what we call the accretion disk, and it is the key to everything that follows. It is the visible consequence of the invisible predator's hunger. The binary nature of this system is a profound and fundamental piece of the puzzle. Without the blue supergiant, the black hole would be just that, a silent, completely invisible patch of darkness in the cosmos. We would have no way of knowing it was there, no way of listening to its quiet gravitational hum. The companion star is the one who gives it a voice. It is the life and light of the blue supergiant that illuminates the darkness not by shining directly on the black hole, but by giving up its very essence to the black hole's insatiable hunger. The X-rays we detect are not from the black hole itself, but from the stolen lifeblood of its companion, superheated and accelerated to impossible temperatures and speeds as it spirals into the abyss. This partnership is also what allowed us in the first place to confirm that a black hole was there at all. In the quiet elegance of their orbital mechanics, the two objects acted as a perfect cosmic scale. By watching the blue supergiant's wobble, by measuring the speed and the size of its orbit, we were able to precisely calculate the mass of its unseen partner. The numbers simply didn't lie. They pointed to something that was far too dense and far too heavy to be anything else. The system itself, in its beautiful fatal dance, provided the undeniable proof. So as we settle into this part of the story, let us appreciate this cosmic duality. we have the life and the light of a colossal star, a being of immense energy and fire, living its short, glorious life. And we have the silent, unseen void, a remnant of a star that lived and died before now an eternal vortex of gravity and darkness. The two of them in their cosmic embrace are not just two objects in space. They are a single intricate system, a testament to the powerful and elegant laws of gravity. It's a dance of life and death, of light and shadow, played out on a scale that is almost impossible for our minds to comprehend. This is the beauty of this kind of cosmic storytelling. We are not just looking at cold, hard facts and numbers. We are watching a drama unfold. The blue supergiant is a tragic hero, a character who is so powerful, so immense, yet is still in the end a victim of its own proximity to a cosmic fate. The black hole is the silent antagonist, a villain whose power comes not from force or from anger, but from a simple, elegant law of the universe. It doesn't have to do anything. It just has to be, and in its being, it draws everything around it inexorably closer. This incredible cosmic ballet is not unique to Cygnus X-1. We have since found many other such pairs, other cosmic couples dancing their fatal waltz across the galaxy. But Cygnus X-1 was the first we ever truly understood. It was the one that opened our eyes to the reality of these binary systems, to the fact that black holes are not lonely, isolated islands of darkness, but often parts of a rich, dynamic, and intricate ecosystem. Their lives are intertwined with the lives of the stars around them, and in this intertwining, they create the most energetic and fascinating phenomena in the universe. The story of the binary system is also a tale of cosmic scale. The sheer size of the blue supergiant, the tight, frantic orbit, the immense distances involved, it all works together to create a picture that stretches our imagination. To think of a star so large that its outer atmosphere is being gently but relentlessly peeled away by a partner that in comparison is almost infinitely small. Can we even truly imagine that a star that burns so hot and so fast that it seems to be in a constant state of cosmic haste, and its companion is a point of stillness, a place where time itself is distorted and motion is a one-way trip to a place of no return? So let us let this image settle in our minds, a beautiful bright star locked in a tight 5.5-day embrace with a silent, unseen partner. The star in its brilliance is telling us the story of the darkness, and the darkness in its silence is shaping the very life and death of the star. It is a cosmic yin and yang, a balance of light and shadow that allows us to witness a part of the universe that was once thought to be purely fictional. It is a testament to the power of celestial relationships and how even the most violent and destructive partnerships can create something beautiful and profound for us to observe. As we drift toward the next chapter, we will turn our attention to what happens to all that stolen matter. The gas and dust from the blue supergiant, pulled from its great body, begins a new journey. It doesn't just fall straight into the abyss. It has to circle, to spin, to wait its turn. And in that waiting, in that final furious dance, it creates a spectacle of light and energy that is so powerful, it reaches across thousands of light years to knock on our door. It is the final brilliant gasp of life before the ultimate silence, and it is the key to understanding the flickering X-rays that began our whole story. It's a story of accretion of a cosmic whirlpool of heat and light, and it is where our journey into the heart of Cygnus X-1 truly begins to get hot. In our last chapter, we watched a cosmic ballet, a grand and powerful dance between a bright, beautiful star and its unseen partner. We saw how the life of one gives a voice to the other, how a visible star illuminates the presence of an invisible force. Tonight, let us gently turn our attention from the dance itself to the nature of the unseen dancer, to the essence of the black hole at the heart of Cygnus X-1. We will try in our slow and thoughtful way to imagine a thing that defies our everyday understanding of reality, a place of such extreme physics that it breaks the rules we thought we knew. What is a black hole? The name itself conjures images of a bottomless pit or a hungry cosmic drain, and in a way that is a beautifully simple metaphor for what it is. A black hole is not a thing you can touch or a place you can stand on. It is quite simply a region of space where gravity has become so overwhelmingly powerful that nothing, not even the fastest thing in the universe, light itself, can escape its pull. It's a point of no return, a place of ultimate cosmic finality. The black hole in Cygnus X-1 is what we call a stellar mass black hole. The name just means that it was born from the death of a star. Think of it not as a mystical object, but as the collapsed, crushed remains of a once magnificent sun. When a massive star, one far larger than our own, reaches the end of its life, it runs out of fuel. The internal pressure that held it up against the crushing force of its own gravity gives way. In a cosmic heartbeat, the entire star collapses inward, squeezing all of its immense mass into a tiny, almost infinitely small point. Cygnus X-1 is the leftover husk of such a colossal sun, a testament to a life lived and ended in the cosmic past. And what a husk it is! The mass of the black hole in Cygnus X-1 is one of its most defining features and a key part of its mystery. Through the quiet, steady observation of its companion star's orbit, astronomers have calculated that it weighs about 15 to 20 times the mass of our Sun. This number is not just a cold fact. It's a profound thought experiment. Try to imagine taking 15 suns with all their immense size, their fire and fury, and squeezing them down into a ball no bigger than a large city or perhaps a small town. The density would be unimaginable. It is a cosmic paradox, the immense weight of many stars compressed into a space that is almost nothing. This is the very essence of a black hole, a place where matter has been crushed beyond all recognition, beyond all of the normal rules of physics. But this isn't a passive stationary void. The black hole at the heart of Cygnus X-1 has another key characteristic that adds a layer of beautiful, dizzying complexity to our story. It spins. And it doesn't just spin a little bit. It spins at a staggering, almost frantic rate, nearly half the speed of light. To give you an idea of that speed, imagine an object at the equator of this black hole spinning at about 150 million meters per second. This extreme rotation is not something new it gained. It is a memory of its life as a star. Just like a figure skater who pulls her arms in to spin faster, the star from which the black hole was born, spinning slowly in its vastness, collapsed inward and conserved all of its rotational energy. All that slow, grand spin was concentrated into a single tiny, frenetic point of light-speed rotation. And this spin has a profound effect, a consequence, that tells us something beautiful and strange about the very fabric of our universe. According to Einstein's theories, space-time is not a rigid grid, but a flexible flowing canvas like a great invisible sheet. A spinning black hole is like a massive unseen whirlpool spinning on that sheet. As it rotates, it drags the fabric of space and time around, with it pulling everything in its vicinity along for the ride. This is a quiet and fundamental truth, a phenomenon known as frame dragging, and Cygnus X-1, with its breakneck spin, is a cosmic laboratory for us to observe and confirm its existence. It's a place where the very nature of reality is twisted, distorted, and dragged along by a silent, spinning predator. As we drift closer, we approach the most famous and mysterious part of a black hole, the event horizon. The event horizon is not a physical wall or a boundary line drawn in space. It is a one-way door. Imagine a great river flowing faster and faster. There is a point where the river's current becomes so strong that no one, no matter how hard they paddle, can turn around and go back. The current is simply stronger than their will. The event horizon is that point in the river of space-time. It is the boundary where the escape velocity, the speed you need to travel to get away from the black hole's gravity, becomes equal to the speed of light. Since nothing can travel faster than light once anything crosses this invisible boundary, it is lost to the universe forever. From our perspective outside, watching an object approach the event horizon would be a strange, almost poetic sight. The immense gravity would warp the light and slow down time for the falling object. It would appear to us to be moving slower and slower, frozen in time at the very edge of the abyss, its light slowly dimming to a final, red-shifted whisper. But for the object itself, from its own perspective, the journey continues. There is no pause, no moment of stillness. It simply continues its inexorable fall into the darkness. The event horizon is the threshold of forever. And Cygnus X-1, in its terrifying elegance, is a living, breathing example of a place where that threshold is as real as the stars we see in the night, and what lies beyond that threshold. What is at the very heart of the black hole, at the center of all that crushed matter and twisted space-time? Here, my friend, is where our quiet, gentle journey must pause, and our scientific understanding must humbly step aside. At the very center lies what we call the singularity. The singularity is a point of infinite density and zero volume, a place where all the mass of the original star and all the matter it has ever consumed is crushed into a single, unimaginable point. But this is where our elegant equations break down. The laws of physics as we know them simply stop working. They give us an answer of infinity, which in science is simply a way of saying, we don't know. This is not a failure of our knowledge, but a beautiful and profound invitation to wonder. The singularity is a great mystery at the heart of reality itself, a place where the universe has an open, unanswered question for us. It is an invitation to dream about a new physics, a new way of understanding the world that we have not yet discovered. So let us not be troubled by this uncertainty. Let us instead be humbled by it. Let us sit in the quiet glow of this cosmic puzzle and simply marvel at the fact that such a thing can exist, a place where the rules of our reality bend and break, where the known world gives way to an uncharted territory of infinite possibility. This is the essence of the invisible dancer. A stellar mass black hole, born of a massive star's death, with the mass of many suns spinning at a dizzying pace, dragging the very fabric of space-time with it and surrounded by a point of no return. It is a cosmic monarch of gravity, a silent king whose power is absolute and whose mystery is profound. But this king is not an isolated ruler. It is in a constant, dynamic relationship with its environment, and in our next chapter, we will see how it manifests its power, not just by its sheer gravitational pull, but by how it transforms the matter that dares to approach it, how it creates a fiery, spinning vortex of light and heat that we can see from thousands of light years away. So let us rest with this image in our minds, a point of infinite density, spinning in the dark, a silent and humble reminder that in the universe, the most powerful things are not always the ones that shine the brightest. The black hole itself may be silent, but its presence creates a cosmic drama of light and fire, and it is that drama we will explore next in the heart of its final beautiful act. We have journeyed through the cosmic ballet of Cygnus X-1, a powerful dance between a shining star and its invisible partner. We have peered into the nature of that unseen dancer, a black hole of immense mass and dizzying spin. Now let us turn our attention to the heart of the action, to the spectacular and violent consequence of their union, a swirling vortex of light and heat, known as the accretion disk. This is the cosmic factory where the stolen starlight is transformed into a powerful X-ray scream, the very light that first knocked on humanity's door and announced the presence of a black hole. Imagine for a moment a cosmic whirlpool, a great flat maelstrom of gas and dust stretching for thousands of miles, all of it stolen from the gentle outward breath of the blue supergiant star. The black hole is at the very center of this maelstrom, a silent, empty eye in the middle of a gathering storm. This is the accretion disk. The matter from the companion star doesn't fall straight into the black hole. Instead, because it still has its own momentum from the star's rotation, it is forced into a flat spinning disk around its new gravitational master. This is a fundamental law of physics in action, the conservation of angular momentum, the same force that makes a spinning top stay upright. In this cosmic scenario, it's the force that makes the great flow of stellar wind from the blue giant flatten and spin, creating this celestial carousel of matter. And what a carousel it is! The particles in this disk are not calmly orbiting. They are packed together, rubbing against each other, smashing into one another at incredible speeds. Imagine the friction of a million planets rubbing against each other all in a rush to get closer to the center of the drain. The closer they get to the black hole, the faster they are pulled, and the more violently they collide. This immense friction and compression causes the matter to heat up to temperatures that are simply beyond our comprehension. We are talking about temperatures of millions of degrees Kelvin, a heat so intense that the very atoms in the gas are stripped of their electrons, turning the matter into a superheated swirling plasma. This is where the story gets its voice. At these extreme temperatures, the plasma in the accretion disk doesn't glow in the gentle, familiar light of a normal star. It's too hot for that. Instead, it emits a far more energetic and powerful form of light X-rays. These are the same X-rays we use in a hospital to see inside our bodies, but on a cosmic scale of unimaginable power. The black hole itself is silent, but its immense gravitational presence has caused the matter around it to become so frenzied, so hot, and so compressed that it screams in this high-energy frequency. This is the X-ray glow that first alerted astronomers to the existence of Cygnus X-1, a brilliant beacon of light born from the final furious journey of matter into a place of utter darkness. The accretion disk is the black hole's most revealing feature. It is a cosmic fingerprint, a telltale sign that an invisible predator is at work. Without this spinning disk of superheated plasma, the black hole would be just that, a patch of empty space indistinguishable from the background. But because the disk is so active, so energetic, we are able to see it from thousands of light years away. The amount of energy released from this tiny region of space is staggering, outshining many entire galaxies in the X-ray part of the spectrum. It is a brilliant, powerful reminder that even in the ultimate void, the final moments of matter can create a spectacle of unimaginable light. What's particularly fascinating about the X-ray light from Cygnus X-1 is that it's not a steady, calm glow. It flickers. It changes in brightness on timescales as short as milliseconds. This rapid variability was one of the key pieces of evidence that first hinted at the object's true nature. Imagine trying to listen to the heartbeat of a person, but you are a million miles away. You wouldn't be able to hear it. But if that person's heartbeat was so loud and so fast that it echoed across the distance, you could begin to learn something about them. The rapid flickering of Cygnus X-1's X-rays told early astronomers that the source of that light had to be incredibly small, a tiny compact region where immense energies were being released in a very short amount of time. It had to be a point source, a compact object like a neutron star, or even more compellingly, a black hole. The variability of this light is like a complex cosmic language. By studying the patterns and the pulses, we can learn about the intricate physics happening in the innermost regions of the accretion disk. We can figure out how fast the black hole is spinning, how its powerful magnetic fields are interacting with the plasma, and how the last final moments of matter are spent just before they fall forever across the event horizon. It's a language of light, and we are still in the early stages of learning to read all of its beautiful, complex poetry. So we have this incredible picture, a luminous, massive star, a king of light and fire in a death waltz with a silent, invisible monarch of gravity. The blue supergiant gives its life its precious stellar matter, and that matter in its final frantic journey spirals into a great disk. In that disk, it is accelerated and superheated, and it screams in a language of X-rays, a powerful final gasp that we can hear across the vast emptiness of space. This is the story of the accretion disk, the visible face of an invisible monster, and the key to our first encounter with a black hole. And what a beautiful and tragic final journey it is. The particles in the disk, for all their frenzy and their light, have only one destination. As they spiral inward, they are caught in the ever-increasing gravitational pull of the black hole. At the very center of the disk, the temperatures reach their peak, the speeds become unimaginable, and a point is reached where the matter can no longer hold its stable orbit. With a final silent and inevitable plunge, the matter falls across the event horizon. It is a one-way trip, a cosmic finality from which there is no escape. The light and heat it generated in the disk are its last testament, its final powerful farewell to the universe. This entire system, this beautiful and violent binary, is a testament to the elegant, brutal truth of gravity. Gravity, which can be the gentle force that holds a galaxy together, can also be the final destructive force that rips a star apart and crushes its matter into a point of nothingness. Cygnus X-1 is the living, breathing, pulsing example of this duality. It is a reminder that in the cosmos, the most powerful stories are often told not with gentle light, but with a silent, unseen hand. And that hand, in its quiet power, can create the most energetic and magnificent light shows in the universe. So we leave the spinning vortex, the fiery disk, and the screaming X-rays of Cygnus X-1, and we turn our attention to what this all means for us, for our understanding of the universe. The discovery of this black hole wasn't just an interesting astronomical fact. It was a confirmation of one of the most profound and beautiful theories in all of science, Einstein's theory of general relativity. The existence of a place where gravity could be so strong that it distorts space-time and traps light forever was not just a wild idea anymore. It was real. And in our next chapter, we will gently explore how the dance of this black hole and its companion provided us with a living laboratory to test the very fabric of our understanding of gravity itself. It's a journey from the fiery maelstrom to the quiet, elegant poetry of a great scientific mind. We have journeyed through the cosmic dance, and we have felt the heat of the accretion disk, the furious final moments of starlight, before it crosses the event horizon. All of this entire magnificent drama, is a testament to the power of a single, fundamental force. Now let us take a step back from the fiery maelstrom and the silent abyss, and look at the grand theory that predicted all of it, Einstein's theory of general relativity. The existence of Cygnus X-1 was not just a random find. It was the universe's first great living laboratory for testing a theory so beautiful and so profound that it changed our understanding of reality forever. For a long time, we thought of gravity as a simple force. An apple falls from a tree, and a planet orbits a sun because of an invisible string of attraction that pulls them together. It was a useful model, a good way to understand the world, but it was incomplete. Einstein's genius was to gently ask us to let go of this idea. He asked us to imagine gravity, not as a force, but as the curvature of space-time itself. Imagine space-time as a great flexible sheet, a vast cosmic canvas that stretches across the entire universe. A planet or a star, being a massive object, is like a heavy bowling ball placed on this sheet. It doesn't just sit there. It creates a depression, a curve in the fabric. A smaller object, like a marble that rolls nearby, doesn't get pulled toward the bowling ball. It simply follows the curve in the sheet. It is a beautiful, elegant, and revolutionary idea. We are not being pulled by gravity. We are simply following the natural contours of a curved reality. Cygnus X-1, with its immense mass, is not a bowling ball on that sheet. It is an infinitely heavy cannonball, a point of such incredible density that it creates a cosmic well of unimaginable depth. The gravity in its vicinity is not just a gentle curve. It is a profound and fundamental warping of the very fabric of space and time. This is why Cygnus X-1 became so important. It was a place where we could look and say, there it is. There is the curve of space-time so deep and so profound that it bends light itself and creates a place from which nothing can ever return. It took Einstein's beautiful abstract idea and made it a tangible, observable reality. But the story doesn't end there. The black hole in Cygnus X-1 has another property, a key characteristic, that adds a layer of beautiful, dizzying complexity: its spin. We spoke of its rapid, almost light-speed rotation, a memory of its life as a star. And this rotation, too, has a profound consequence on the very fabric of our universe. A spinning black hole doesn't just create a deep well in the space-time sheet. It creates a whirlpool. It drags the very fabric of space and time around, with it pulling everything in its vicinity along for the ride, like a spinning top, twisting the water around it. This is the phenomenon of frame dragging, a subtle and elegant prediction of general relativity that seemed almost too strange to be true. Cygnus X-1, with its fiery accretion disk, gave us a way to finally see this in action. The matter in the disk is not just spiraling inward. Its orbit is being influenced by this twisted, spinning space-time. By observing the patterns and the pulses of the X-rays coming from the innermost part of the disk, scientists could measure this effect. They could see the telltale signs of the fabric of reality being twisted by a silent, spinning predator. It was a subtle and beautiful confirmation of a profound theoretical prediction, an undeniable sign that the universe itself was playing by Einstein's rules. Now let us turn to another part of this great theory, a prediction so grand that we have only recently been able to confirm it. Gravitational waves. Just as a pebble dropped in a pond sends ripples across the water, a massive violent event in space-time, like two black holes colliding, sends ripples through the very fabric of reality. These ripples are gravitational waves. Cygnus X-1, in its beautiful steady waltz with its companion star, is also a source of these waves. The two massive objects orbiting each other in a frantic embrace are constantly creating subtle ripples in the space-time around them. However, Cygnus X-1's orbit is stable, and its dance is a steady one. It is not yet a violent collision. So while it is a source of gravitational waves, the ripples it creates are so subtle and so slow that our current instruments, brilliant as they are, cannot yet detect them. It is as if we are listening to a faint, beautiful hum from a great distance, and our ears are not yet sensitive enough to hear the melody. But this is not a failure of the system. It is a challenge to our technology, a silent invitation to build more sensitive instruments, to listen more carefully. And when we do, when we are able to finally hear the hum of Cygnus X-1's gravitational waves, it will be another profound moment in our long, gentle journey of discovery. The story of Cygnus X-1 and general relativity is perhaps best personified by a famous friendly disagreement between two of the greatest minds of our time, Stephen Hawking and Kip Thorne. The debate over whether Cygnus X-1 was a black hole was so heated, so fundamental to the very core of physics, that in 1974, they made a bet. Hawking, a brilliant theoretician, was the skeptic. He bet that Cygnus X-1 was not a black hole. Thorne, a visionary and confident theorist, was the believer. He bet that it was. The stakes were not money or fame, but something more fitting for their brilliant minds. If Hawking won, he would receive a subscription to a satirical British magazine. If Thorne won, he would receive a subscription to a more flamboyant and perhaps slightly less intellectual publication. This bet was a beautiful and profound moment in the history of science. It was not a personal feud, but a testament to the scientific process itself. It was a way of publicly acknowledging the uncertainty, the honest debate, and the courage it takes to stand by an idea that is unproven. For 16 years, the bet stood. But as more and more evidence accumulated, as the orbital measurements became more precise, as the X-ray emissions were studied in greater detail, the scales began to tip. All the evidence pointed to the same conclusion: Cygnus X-1 was a black hole. In 1990, with his customary humility and grace, Hawking conceded the bet. He signed the paper, and with that single act, he not only honored the spirit of scientific inquiry, but also marked a profound moment of consensus. It was no longer a question of belief. It was a question of observation and undeniable evidence. The bet was a beautiful human drama played out against a cosmic backdrop, and its resolution was a quiet triumph for a theory that was once considered too strange to be real. So as we close this chapter, let us rest in this thought. The universe is a place of profound elegance. The laws that govern it, as described by Einstein's beautiful equations, are not just abstract ideas. They are a literal physical reality. And in the heart of the Cygnus constellation, a black hole and its companion star are performing a cosmic dance that is a living, breathing testament to their truth. Cygnus X-1 is more than a black hole. It is a bridge between theory and reality, a quiet confirmation that the universe is a place of such immense wonder that sometimes the greatest truths are the ones that are the most difficult to believe. And with the confirmation of its existence, we were finally given permission to dream bigger, to ask deeper questions, and to embrace the fact that we have only just begun to see the full beautiful scope of the cosmos. But the story doesn't end with this triumph. The confirmation of Cygnus X-1 as a black hole did not close the book on its mystery. In many ways, it was just the first page of a new chapter. The universe, in its elegant way, has a habit of revealing one secret only to hide another in its place. And in the heart of this black hole system, there are still puzzles that our best minds are trying to solve, still beautiful questions that remain unanswered. And it is to those mysteries to the heart of the great cosmic enigma that we will turn our attention next. In our last chapter, we celebrated the triumph of a beautiful idea, the moment when the elegant theory of general relativity was confirmed by the reality of a black hole. But in the quiet heart of the cosmos, a solution often gives birth to a new, more profound mystery. The discovery and confirmation of Cygnus X-1, rather than closing the book, opened a new one filled with pages of beautiful, unanswered questions. Tonight, we will not seek answers, but simply sit in the presence of these puzzles to honor the humility of science and the endless beautiful work of the human mind. The first and most enduring mystery of Cygnus X-1 is what we call the formation paradox. When we determined that the black hole had a mass of about 15 to 20 times that of our Sun, it was a moment of profound confusion. Our best models of how stars live and die told us a very different story. According to these traditional models, a star massive enough to form a black hole of this size should have lived a life of such violent stellar winds and intense pulsations that it would have shed most of its outer layers long before its collapse. Imagine a giant fiery dandelion constantly blowing its seeds away. By the time it was ready to die, there wouldn't have been enough material left to form such a colossal black hole, the existence of Cygnus X-1. This cosmic heavyweight forced us to gently question our own assumptions. How did it get to be so massive? Did its progenitor star, the Sun, from which it was born, have a different, more quiet life than we imagined? Or perhaps the star's death was more a direct catastrophic implosion than a slow, leisurely shedding of its layers. The paradox is a silent, beautiful challenge to our understanding of the very life cycles of the most enormous stars in the universe. It is a puzzle that stretches our imagination and forces us to reconsider the cosmic stories we tell about the lives and deaths of celestial bodies. This challenge leads us to another fascinating layer of the mystery, a concept we call metallicity. In astronomy, the word metal is used a little differently than in everyday language. It refers to all elements heavier than hydrogen and helium. When a star is born, its metallicity, or the abundance of these heavier elements in its makeup, has a profound effect on its life. We believe that stars born in the early universe before many generations of stars had lived and died to create these heavier elements had very low metallicity. These metal-poor stars would have had weaker stellar winds, and thus they would have held on to more of their mass as they aged. When they died, they could have collapsed to form enormous black holes far bigger than what we see today. But here is where the puzzle of Cygnus X-1 deepens. The star that gave birth to the black hole and its companion are part of a later generation of stars. They have a metallicity that is much higher. According to our theories, a star with that level of heavier elements should have had strong stellar winds, shedding a great deal of its mass and leaving behind a much smaller black hole. So how did this particular system manage to produce such a colossal black hole? Did it form in an unusual way? Did it perhaps merge with another star or consume its neighbor at a much faster rate? This mystery of metallicity is a quiet reminder that the story of stellar life is far more complex and nuanced than our simple models can capture. And what about the heart of the black hole itself, the place we spoke of in our last journey? The singularity. It remains a profound challenge, a place where all of our beautiful, elegant equations of general relativity simply break down. Our theories tell us that all the immense mass of the black hole is crushed into a single point of zero volume, a point of infinite density. But can that truly be? Can something with zero volume hold a mass of 15 suns? It is a concept that our minds struggle with, a place where our physics hits a wall and simply says, I don't know. This is not a failure of our knowledge, but an invitation to a new kind of thinking. The singularity is a blank page in our cosmic map, a place where we are forced to admit that we are missing a fundamental piece of the puzzle. We believe that to understand what happens at this point, we need a new kind of physics, a new language to speak. This new language would have to be something we call quantum gravity, a theory that would gently weave together the laws of the very large, as described by Einstein, with the laws of the very small, the strange and beautiful world of quantum mechanics. The singularity in Cygnus X-1 is a constant quiet whisper, a reminder that we are still searching for that language, that we are still standing at the very edge of our understanding. Then there is the puzzle of the black hole's frantic spin. We know it spins at a staggering rate, nearly half the speed of light. But how did it get that way? Was the original star from which it was born spinning that fast? Or did the black hole spin up over millions of years by consuming the matter from its companion star, a process that would add to its angular momentum? The answer is likely a combination of both, but the exact story is still being written. The spinning conundrum of Cygnus X-1 is like trying to read a very old, very faint book. We have the letters and the words, but we are still trying to piece together the full, complete narrative of how its life began and what cosmic forces shaped its existence. And this is the gentle, beautiful essence of science. We have found a black hole, and we have confirmed our theories. But in doing so, we have also found new layers of mystery, new puzzles that challenge us to think bigger, to dream a little more. The existence of Cygnus X-1 is a constant quiet reminder that our universe is a place of such immense wonder and strange beauty that we may never run out of questions. It's an invitation to simply sit with the unknown, to not be troubled by it, but to be inspired by it. So as we rest here with these unanswered questions, let us appreciate the humble and patient work of the human mind. The search for answers to these mysteries is what drives us forward, what pushes us to build better telescopes, to develop new theories, and to look at the universe with a fresh and curious eye. Cygnus X-1 is not a finished story. It is an ongoing conversation, a beautiful dialogue between humanity and the cosmos. And in our next journey, we will take a gentle look at the amazing tools and technologies we have built to listen more closely to that conversation, to peek into the heart of these mysteries, and to slowly, patiently begin to find some of the answers to these beautiful, profound questions. We have sat with the great mysteries of Cygnus X-1, the profound questions about its immense mass and its frantic spin. These questions, however, are not just quiet invitations to wonder. They are also powerful calls to action. To answer them, humanity has had to do something brave and creative. We have had to build new eyes and new ears, new ways to perceive a universe that remains largely invisible to us. Tonight, we will take a gentle journey through the amazing tools and ingenious techniques we have developed to study this invisible predator, to listen to its whispers, and to try and piece together its story. Imagine you are a detective, but your crime scene is thousands of light years away. You cannot touch the evidence, and you cannot talk to the witnesses. All you have are the faint echoes and shadows the criminal leaves behind. This is the challenge of studying a black hole. We cannot see it directly, but we can see its footprint. We can hear the sound it makes in a language of light. We are still learning to read, and we can observe the way it moves, the very fabric of space and time. Our tools are not for seeing the black hole itself, but for observing the magnificent cosmic drama that its existence creates. Our first and most crucial eyes in this investigation are the X-ray telescopes. These are the direct descendants of the crude rocket-borne detectors that first found Cygnus X-1 in the 1960s, but they are far more refined, far more sensitive. A modern X-ray telescope, like the majestic Chandra X-ray Observatory, does not sit on the ground for our atmosphere. That beautiful blue shield would block its view. Instead, it orbits the Earth, a silent, patient sentinel, floating above the atmospheric veil. And how do these telescopes work? It's a beautiful piece of cosmic ingenuity. You cannot make an X-ray telescope with a normal mirror, for X-rays are so energetic they would simply pass through it. So scientists came up with a clever solution. They built a series of highly polished nested mirrors that are shaped like long, elegant funnels. The mirrors are positioned at a very shallow angle, and the X-rays, instead of passing through, hit the mirror and skip off it, much like a stone skipping across a still pond. By having a series of these mirrors, they are able to gently nudge the X-rays one by one until they are all focused onto a detector. This allows us to create beautiful high-resolution images of the X-ray emitting regions around the black hole, images of that fiery spinning accretion disk, images of the very heart of the cosmic maelstrom. Chandra and other X-ray observatories have given us invaluable insights. They have confirmed the rapid flickering of Cygnus X-1, providing crucial evidence that the light source is indeed coming from an incredibly compact object. They have given us detailed maps of the X-ray spectrum, the complex color palette of the high-energy light. By studying this spectrum, scientists can figure out the temperature of the gas, its speed, and the conditions of the plasma just before it plunges across the event horizon. These are the eyes that have let us look at the scream of stolen starlight and begin to understand the physics of its final frantic moments. But our detective work doesn't stop there. We also use another set of eyes, an ear's eyes, that see a different kind of light, the radio telescopes. These are the great silent dishes that you see dotted across the landscape, listening to the universe in a language of long, lazy waves. Radio telescopes first revealed another spectacular part of the Cygnus X-1 story, the relativistic jets. Imagine two massive invisible lighthouses shining not with visible light, but with a powerful radio wave beacon. These are the twin streams of high-energy particles that are shot out from the poles of the black hole at nearly the speed of light. To get a clearer picture of these magnificent jets, we use a technique called interferometry. This is a beautiful and elegant idea. Instead of using a single massive radio dish, we use many dishes, sometimes spread across an entire continent. We then combine the signals from all of these dishes so that they act as a single giant virtual telescope. It's like having a pair of eyes that are 1,000 miles apart, giving us a resolution so fine that we could read a newspaper from a great distance. This technique has allowed us to create incredibly detailed maps of the jets, to see their intricate structure, and to understand how these powerful streams of particles are being launched and shaped by the black hole's extreme magnetic fields and its frantic spin. And what about our first, most ancient tools? The optical telescopes that look at the universe in visible light are still indispensable. They cannot see the black hole, but they can see its partner, the brilliant blue supergiant star. By watching the star's light, and by measuring the subtle Doppler shift of its spectrum as it wobbles in its orbit, we can precisely determine its speed. And as we learned before, by using the simple, elegant laws of gravity, this gives us the information we need to weigh the unseen object it's dancing with. The optical telescope is the tool that gave us the weight of the black hole, the single most important piece of evidence that it was a black hole at all. It is a beautiful irony that a tool designed to see light in its most gentle form was the key to unlocking a secret about the absence of it. But the story of our technology is a story of constant evolution, of a continuous march into the future. We are not content with what we have. We are always listening more carefully. The next great frontier is in a form of perception that Einstein himself predicted: gravitational waves. We have built magnificent instruments, like LIGO and Virgo great laser arms, that stretch for miles, designed to detect the tiniest ripples in the fabric of space-time. So far, they have detected the crashing violent ripples from the collision of black holes, the cosmic equivalent of two dancers slamming into each other. But one day, our instruments may be sensitive enough to detect the quiet, constant hum from a stable binary system, like Cygnus X-1, the subtle and beautiful song of its orbital waltz. This will give us a new, profound layer of information, a new way to listen to the universe, one that doesn't rely on light at all. And as the data from all of these magnificent instruments pours in, we face a new kind of challenge, sifting through a sea of information so vast that a human mind could never hope to understand it all. This is where our most modern tools, artificial intelligence and machine learning, come into the picture. Imagine an AI as a tireless detective trained to look for patterns and anomalies in the data that a human might miss. It can listen to the flickering of the X-rays, it can sift through the complex spectrum, and it can find subtle clues about the black hole's spin, its mass, and its behavior that would be hidden from us. AI is not just a tool for processing data. It is a new kind of partner in our long, gentle quest for knowledge, helping us to listen more carefully and to see more clearly than we ever could before. So as we close this chapter, let us take a moment to honor the ingenuity and the persistence of the human spirit. The tools we have built to study Cygnus X-1 are not just pieces of metal and electronics. They are a testament to our curiosity, to our desire to know, and to our ability to reach beyond the limits of our own senses. We have built eyes that see an invisible light, ears that listen to the silent hum of the cosmos, and minds that can process a cosmic story so vast and so complex that it defies our natural understanding. It is in this quiet, determined effort that we find a great and beautiful truth, that even in the face of the most profound and invisible mysteries, we will always find a way to listen. And what we hear, what we see, is a cosmic drama that reaches far beyond Cygnus X-1 itself, a drama that shapes the very fabric of its cosmic neighborhood. And it is to that larger story of influence and impact that we will turn our attention next. In our last chapter, we marveled at the magnificent tools of human ingenuity, the X-ray eyes and radio ears we have built to listen to the whispers of Cygnus X-1. We saw how these instruments allow us to observe a cosmic drama unfolding. But the story does not end with the performance itself. The presence of a black hole and the frantic dance it performs has a ripple effect that extends far beyond its immediate partnership. Tonight, we will gently explore the profound influence of Cygnus X-1 on its cosmic neighborhood, to understand how a single silent object can become a catalyst for both creation and destruction, a force that shapes the very fabric of its surrounding interstellar environment. The most immediate and obvious interaction is, of course, with its companion star. The blue supergiant, so grand and luminous, is not just a dancer in this cosmic ballet. It is also an active participant in its own slow, gentle destruction. The black hole is not a passive observer. It is a catalyst for change, slowly but inexorably altering the life and ultimate fate of its companion. Its immense gravitational pull is constantly at work siphoning off the outer layers of the star, a process that accelerates its companion's life cycle. The blue supergiant's fate is no longer its own. it is now inextricably linked to the dark object it orbits. It is a story of a one-sided cosmic symbiosis, where the light and life of one being is the very fuel for the quiet, eternal existence of another. But the black hole's influence reaches far beyond the graceful tragedy of its companion. As we discovered in our last journey, Cygnus X-1 is not just a silent drain. It is also a cosmic engine producing powerful energetic streams of particles from its poles, the relativistic jets. Imagine these jets not just as signals for our radio telescopes, but as powerful cosmic lighthouses. They are magnificent invisible beams of energy and matter that carve through the interstellar medium, the vast empty space between the stars. And as they do, they leave a profound mark on the cosmic canvas. As these jets blast outward at nearly the speed of light, they are like powerful energetic ships plowing through a still cosmic sea. They create immense shock waves that ripple through the gas and dust in their path. This collision generates immense heat, ionizing the surrounding gas and carving out great bubbles of hot plasma in the interstellar medium. These bubbles are not just empty spaces. They are regions of change of powerful energy transfer. The jets of Cygnus X-1 are a force of cosmic resculpting, pushing and pulling on the fabric of its surrounding environment, a constant energetic reminder of the powerful silent presence at its heart. And in this great act of cosmic resculpting, we find a beautiful, elegant paradox. The black hole, in its destructive act, can also be a quiet source of creation. The intense radiation from the accretion disk and the heat from the jets in the immediate vicinity of the black hole can inhibit star formation. It blows away the cold, dense molecular clouds, the very nurseries where new stars are born. Imagine a gardener with a powerful torch accidentally scorching a patch of fertile soil and making it impossible for seeds to sprout. This is the black hole's role in its immediate neighborhood, a force that suppresses the birth of new stars. But the story is not that simple. At the edges of those powerful jets where the shock waves are still strong, but the heat is not as intense, something else happens. The collision of the jet with the interstellar medium can compress distant gas clouds, squeezing them together. This compression is sometimes the very trigger needed to overcome the internal pressure of the cloud and kickstart the formation of a new generation of stars. Imagine that same gardener, but the torch they hold creates a powerful wind that in its journey creates a perfect fertile ring of compressed soil. Far away from the initial burn, a perfect place for a new garden to bloom. This is the dual nature of Cygnus X-1's influence. It is both a destroyer and a quiet, indirect creator, a catalyst for new life born out of its own relentless, powerful death. What is so important about this is not just the immediate effect on the neighborhood of Cygnus X-1, but what it tells us about the universe as a whole. Cygnus X-1 is what we call a stellar mass black hole, a relatively small and local example of a much grander, more powerful, cosmic drama. At the heart of almost every large galaxy, including our own Milky Way, there is a supermassive black hole, a true cosmic titan with a mass of millions or even billions of suns. These galactic behemoths also have accretion disks and powerful jets, but on a scale so vast, they influence the destiny of entire galaxies. Cygnus X-1 is our close-up, high-resolution laboratory. It is a small-scale, beautiful model of a much grander, more complex engine. By studying its behavior, by listening to its X-rays and watching its jets, we can begin to understand the physics of how those supermassive black holes regulate star formation and how they shape the evolution of an entire galaxy. It helps us to solve the grand cosmic puzzle of how the universe is structured and how the smallest, most powerful objects can have an impact on the largest, most majestic of cosmic entities. It is a beautiful reminder that in the universe, everything is connected, and that the story of a single star in a binary system is also a small part of the story of a galaxy. So as we close this chapter, let us leave the cosmic stage of Cygnus X-1 with a newfound appreciation for its profound influence. It is a destroyer of a star and a sculptor of its own local interstellar medium. It is a suppressor of life and an indirect catalyst for its creation. It is a small, quiet, and powerful beacon that helps us understand the grand sweeping narrative of galactic evolution. It is a testament to the elegant, powerful, and sometimes contradictory nature of the cosmos, a place where a single object can hold within it the secrets to both the smallest of stories and the grandest of cosmic epics. And as we leave the science behind, we will turn our attention to the final, most human part of our story. We will explore how Cygnus X-1, this silent predator, has become a part of our own narrative, how it has inspired our art, our music, and our very way of seeing the world. We have journeyed through the science of Cygnus X-1, from its first faint X-ray flicker to its profound influence on cosmic processes. We have marveled at the elegant physics and the ingenious tools we use to study it. But the story of this celestial object is not confined to the quiet labs of scientists and the remote reaches of space. In a beautiful and perhaps inevitable turn of events, Cygnus X-1 has transcended its scientific origins to become a powerful symbol in our own human story. Tonight we will gently explore this final, most intimate chapter of its legacy, how a black hole, a place of ultimate cosmic silence, has inspired our music, our art, our literature, and our very way of seeing the universe. Before the 1960s, a black hole was a theoretical ghost, a mathematical curiosity that existed only in the equations of brilliant minds. It was a footnote in the grand story of the universe. Cygnus X-1 changed all of that. It gave us a tangible object, a location, and a name to attach to this mind-bending idea. It was no longer a theory. It was a real physical place that existed in our own galaxy. And once an idea moves from the realm of the abstract to the tangible, it is quickly adopted by the human imagination. Cygnus X-1 became a cosmic icon, a star not of light, but of the human mind. Perhaps the most famous and poetic of these cultural interpretations came from the Canadian progressive rock band, Rush. In the late 1970s, they dedicated a two-part epic song to this celestial object. Cygnus X-1 Book 1 The Voyage and Cygnus X-1 Book 2 Hemispheres were not just songs. They were a fusion of scientific inquiry and a fantastical narrative. The music itself was dark, intense, and complex, full of intricate rhythms and soaring melodies that evoked the frantic, dizzying nature of the black hole's gravity and the silent vastness of space. It was a beautiful act of creative translation, taking the cold, hard facts of astrophysics and turning them into a powerful, emotional journey. The lyrics told the story of an intrepid explorer, a character who in a ship named the Rocinante ventures into the black hole itself, drawn by an irresistible curiosity. The story is a metaphor for the human quest for knowledge, a journey into the unknown, where the ultimate truth might come at the cost of one's own existence. The music of Rush introduced a generation of young people to the name Cygnus X-1, sparking their own curiosity about what this thing was. It was a beautiful and powerful bridge, showing that the pursuit of science can be as thrilling and as dramatic as any adventure story. In the realm of science fiction and literature, Cygnus X-1 became a powerful and enduring trope. It was no longer just a black hole. It was a character in its own right. Authors used it as a gateway to other dimensions, a cosmic wormhole that could transport a starship across vast distances. It was imagined as a source of immense untapped energy that a future civilization might try to harness, a tantalizing prize that could be both a blessing and a curse. It served as a dramatic backdrop for stories of human courage and folly, a silent, powerful presence that tested the limits of our technology and our spirit. This celestial object, a real piece of our galaxy, provided a grounding and a sense of realism to stories that were otherwise pure fantasy. It was the moment a real scientific discovery got to be part of our dreams. This cultural translation was not just about entertainment. It had a profound effect on public understanding. For so long, black holes were a purely theoretical construct, a strange and difficult idea to grasp. But with the discovery and the popularization of Cygnus X-1, they became a tangible, real thing. The public now had a name to attach to a mind-bending concept. The dramatic narrative of its discovery, the X-ray flicker, the invisible companion, the cosmic waltz, was a perfect story for educators and science communicators. It was a way of making the abstract concrete, of making the mind-bending comprehensible. Cygnus X-1 became the poster child for the reality of black holes, a testament to the fact that sometimes the universe is even stranger than we can imagine. The human element of the discovery played a huge role in this cultural resonance. The famous Hawking-Thorne bet was not just a scientific debate. It was a fascinating human drama that was captured by the public imagination. It showed that science is not a dry, rigid process of proving things. It is a vibrant, passionate, and deeply human endeavor, filled with brilliant minds, friendly rivalries, and the profound humility to admit when you are wrong. When Stephen Hawking, one of the greatest scientific minds of all time, conceded the bet in 1990, it was not a defeat. It was a powerful, beautiful moment of scientific integrity that spoke volumes about the nature of truth. It showed the public that science is not about being right. It is about seeking the truth, no matter where it leads. And so the story of Cygnus X-1 is a story of a silent, invisible force that found a voice in our culture. It is a story of how a scientific discovery in its purest form can inspire our greatest works of art, our most thrilling stories, and our most profound moments of wonder. It is a testament to the fact that the universe does not just exist outside of us. It also exists within us, in the way we tell stories, in the way we create music, and in the way we are driven to understand the great mysteries around us. Cygnus X-1, in its silent, powerful existence, has become a beautiful, permanent part of our own cosmic narrative. As we drift toward our final chapter, let us hold on to this thought. We have moved from the quiet flicker of a detector to the grand sweep of a cosmic dance, to the intimate echoes of that dance in our own creative souls. We have seen how Cygnus X-1 is a bridge, a living link between the mind of a theoretical physicist and the mind of a musician. In our final journey, we will take one last gentle look at this remarkable object. We will place it in its true grand context, comparing it to other black holes in the universe and reflecting on its enduring legacy. It is a story of a small star and a silent predator that helped us to understand the greatest story of all, the story of our universe itself. We have journeyed together from a quiet lab in the 1960s to the fiery heart of a cosmic drama. We have celebrated the brilliance of human ingenuity and the humbling beauty of scientific truth. Tonight, as we reach the end of our story, let us take one final gentle look at Cygnus X-1 and place it in its true context as one small but profoundly important piece of the grand sprawling narrative of the universe itself. It is a story that goes beyond a single star and a single black hole. It is a story that helps us understand the greatest story of all. We have come to know Cygnus X-1 as a stellar mass black hole born from the collapse of a single massive star. It is a king in its local cosmic village, a powerful presence that dominates its immediate surroundings. But in the wider kingdom of the cosmos, there are rulers of a different scale. At the heart of almost every large galaxy, including our own Milky Way, there is a giant of a different nature, a supermassive black hole. Our own galactic center is home to one of these titans, an object we call Sagittarius A, a behemoth with a mass of about 4 million suns. Cygnus X-1 is to Sagittarius A what a single powerful wave is to a great ocean. The physics that governs their existence is the same, but the scale of their influence is unimaginably different. While Cygnus X-1's drama affects a single star and a few clouds of gas, Sagittarius A's presence influences the lives of billions of stars, shaping the very structure and destiny of our entire galaxy. It is a beautiful and humbling truth that our tiny nearby black hole in its fierce little dance acts as a perfect laboratory for us to understand the colossal grand-scale behavior of the galactic titans. By studying the simple clockwork model of Cygnus X-1, we can begin to unlock the secrets of the grand complex engine that powers our entire galactic home. And what about the role of Cygnus X-1 in the grand narrative of cosmic evolution? In its existence, it represents a crucial and beautiful part of the universe's life cycle. The star that gave birth to it lived a magnificent, though short life. In its furious existence, it fused lighter elements into heavier ones in its core elements, like carbon, oxygen, and iron, the very building blocks of life. When that star collapsed, it enriched the surrounding space with these elements, seeding the interstellar medium with the raw materials for future generations of stars, planets, and perhaps even life itself. Cygnus X-1 is not just an object of destruction. It is also a quiet, profound part of the cosmic recycling program, a testament to the fact that in the universe, the end of one story is often the beginning of a new one. But what will be the final fate of Cygnus X-1 itself? This is a question we can answer, though its final chapter is still millions of years away. The black hole is in a constant, relentless process of consuming its companion star. The blue supergiant, so luminous and so grand, will not last forever. It is living its life in fast forward, and eventually it will burn out. When its fuel is exhausted and it runs its course, the flow of matter that feeds the black hole's accretion disk will slow and then stop. The furious X-rays scream. The voice that first told us of the black hole's presence will slowly fade away. The black hole will then become what we always imagined it to be, a truly silent, solitary, invisible object, a quiet point of immense gravity drifting through the vast emptiness of space. Its dramatic life of light and noise, a distant memory. It is a poignant, almost melancholic thought that the very thing that made it famous will one day be the very thing that it loses. As we look even further out, we can connect the quiet lessons of Cygnus X-1 to the grandest, most mind-bending mysteries of all dark matter and dark energy. The link here is not a direct one, but a link of understanding. Cygnus X-1 provided us with a living laboratory to test Einstein's theory of gravity in its most extreme and powerful form. This is a crucial fundamental piece of our cosmic toolkit. The more we understand gravity, the more we can understand its effects on the grandest scales. And it is on those grand scales, in the rotation of galaxies and the accelerating expansion of the universe, that we found the silent, invisible fingerprints of dark matter and dark energy. Cygnus X-1, in its quiet, fierce way, helps us to refine the very language we use to speak about these cosmic titans, giving us the tools we need to understand the vast unseen forces that shape our universe's ultimate destiny. So where does that leave us? As our gentle journey comes to an end, let us sit with these thoughts. Cygnus X-1 is a story of discovery, of human ingenuity, of cosmic recycling, and of the profound connection between the smallest, most powerful events and the grand, majestic sweep of cosmic history. It is a beautiful reminder that our universe is a place of such immense wonder and strange beauty that we may never run out of questions. It is a quiet invitation to embrace the mystery, to honor the humility of a mind that can admit what it does not know, and to find a sense of peace in the vastness of the unknown. Look up at the night sky tonight, my friend. And when you see the constellation of the Swan, the beautiful bird soaring across the Milky Way, remember that tucked away within its silent wings is a story of a fierce cosmic dance, a story of a brilliant star and an invisible void, and a story of a quiet, patient journey that began in a distant lab and ends right here in the quiet of your own mind. Let the knowledge bring you not questions, but a sense of peace. The universe is a vast and mysterious place, and we are privileged to be here to be a part of it and to simply be able to wonder.